Hi there, thank you for joining. In this week's video, we'll be showing you how we created a special pin for my little nephew's team based on this sketch they've drawn. Notice it's crafted from multiple materials, combining a laser cut plywood insert with a 3D printed frame to achieve a natural look and allow for precise engraving. I'm Gergo, and you're watching Gergo Print 3D, the growing YouTube channel about my 3D printing adventures and all kinds of DIY projects. All my videos include high-quality subtitles, which translate well into other languages too. Be sure to enable them if needed. So, in this video, we will walk you through the 3 software and 3 hardware tools we've used to create this cool pin from scratch. You'll learn about Autodesk Fusion, where we've designed the parts not only for 3D printing, but now for laser cutting as well. Orca Slicer, which helped us prepare the prototype quickly for the Comgo T300, still the fastest 3D printer in my fleet that can start printing in just 2 minutes. But you'll also see my Sovol SVO8 in action, the printer we used for the mass production of all 17 pieces at the highest quality. And introducing Lightburn for setting up the laser engraving job on the MacBow X5 wirelessly, since this laser cutter is now outside of the window of my office. Plus, a special deal for you. Get your Lightburn license at a discount from geekbuying.com, who also provided the MacBow X5 laser cutter for this project. So, let's get started and make something amazing. We use the command insert canvas to import their drawing into Fusion. Set up its size, created a sketch, and I had my nephew trace half of the shape using the line tool. He did a great job with the tracing. We used the fillet tool to smooth the curves, then made the crest perfectly symmetrical by mirroring the half on the middle line. This is going to be the shape of the laser cut inlay. Then, using the offset tool, we added a 2mm border that, along with the backside, is going to be 3D printed. Before going on with the design of the 3D printed part, let's export the sketch in DXF format for use in Lightburn. This was actually the very first real project I used Lightburn with, the MacBow X5. So much more powerful than Laser GRBL or the free MKS Laser app that came with the engraver. I found a very space-efficient way to store this large device. It's now hanging on the wall of my little studio room. It takes just 7 minutes to set it up for use on my porch, right outside this window, so the smoke doesn't stink up the house. My desktop computer inside can connect to the laser cutter over Wi-Fi. The default password is 1234567 I had to create a virtual serial port over TCP using this Tibo VSP app, a free little utility. You can pause the video for my settings. I'll put a link to this program in the description below. So, we dropped the DXF vector graphics into Lightburn and simply selected and deleted the outside border, which we don't need for the insert. We are going to recreate the graphics in their sketch using clipart and tools in Lightburn. First, we searched for a bullseye image, imported using copy-paste, resized carefully, then used a circle to mask out the corners. Next, we added the 50-50, positioned just above the bullseye image. We also drew the dot at the bottom using the circle tool. Finally, imported the image of the bow and arrow, pointed at the dot, and mirrored it just as they are on the original sketch we worked from. Let's talk about layers, which make Lightburn so powerful. Each layer describes a task that the laser engraver will carry out. First, we have the text and the dot. We assign these to blue layer 1 and set these up to be filled drawings at 2000 millimeters per minute at 30% power. Next, the 3 clip art pictures are assigned to red layer 2. These are to be output in image mode, same speed and power. Last, we have the border on green layer 3, which is set to cut at a slower 300 millimeter per minute speed, 100% power, and I found 2 passes produce the cleanest cut on this 3.5 millimeter plywood. Notice I had air assist enabled for all tasks, but it is of course most important for cutting so the smoke doesn't get in the way of the laser beam. And yes, we also have the masking circles assigned to yellow layer 4, which I called hidden and disabled its output. I need them only for masking, nothing else. Is this the best way to do this? Please let me know in the comments. Anyway, great. So theoretically, we could just hit start and it would carry out the tasks in sequence on the X5. But I found the buffered Wi-Fi connection to be flaky and the job would randomly hang, burning a hole where the laser beam stopped. So I did what we are actually used to do with all our 3D printers, store the G-code file on the device itself and execute it locally. First, you will need a micro SD card for this. My X5 did not come with one, but this 16 gigabyte card works well. Second, I haven't found a way to send the G-code file from Lightburn to the engraver directly, which is pretty surprising since in 3D printing world, all slicers are capable of this. Please leave a comment if you know a way to do this. We could save G-code, however, and use the engraver's web interface to upload and execute it. Not so bad. And for preview features, we can still use the frame buttons in Lightburn. It's just longer jobs that fail. Maybe it's my computer or Wi-Fi is at fault. Amazing. We now had the laser engraved insert and it turned out way beyond our expectations. Back to Fusion for the 3D printed housing part. We added cutouts for the 2 millimeters wide and 30 millimeters long safety pin, a 7 millimeter hole for the head, and a 5 millimeter hole for the spring. We extruded the sides of the frame by 3.6 millimeters, the thickness of the plywood. Then we extruded the back of the housing by just 1 millimeter. Finally, removed a 0.4 millimeter deep groove to make room for the shank of the safety pin behind the inlay. We exported the STL mesh for Orca Slicer using the standard PLA presets. It was projected to take less than 4 minutes to print this prototype. My upgraded Combo T300 is ideal for quick print jobs like this because it can heat the bed and nozzle in under a minute. Since I've coupled the Z motors, no preprint gantry leveling is necessary. Additionally, with Christian Vick's stored temperature-dependent meshes, there is no need for adaptive mesh creation either. This printer can literally start printing in 2 minutes after flipping the power switch on. For a 3.5 minute print job, quad gantry leveling and adaptive mesh creation on a Voron-like printer like the SVO8 would add a 5-minute overhead, more than doubling the print time. So here's the question of the day. Will the laser cut inlay and the safety pin fit into the 3D printed case now? Amazingly, they all did. Right at our very first attempt, we were overjoyed. We quickly multiplied the laser project using the handy grid array command in Lightburn and sent the job to the engraver. At the same time, we cloned the part in OrcaSlicer and switched to the SVO8 for its bigger build surface to print all the pins at once. While these two worked on mass production, the laser engraver in 2D and the 3D printer, well, in 3D, we also used the time productively, fighting in 2D on the computer screen and in 3D in the VR headset. We wrapped up the day with my nephew eagerly taking charge of assembling all 17 pins by himself. The laser cut and 3D printed parts fit together so perfectly and tightly, they snapped into place and held firmly without any need for glue. What a great project, combining the power of 3D printing and laser cutting. If you're thinking about expanding your toolkit with a laser engraver, now is the perfect time to do so with geekbuying.com's 12th anniversary sale. Check out the links and coupon codes in the description below to enjoy significant savings now. And I do recommend switching to Lightburn. It is what OrcaSlicer is to 3D printing, whether you buy it together with a device or as a separate add-on later, you'll find the best price for a Lightburn license on geekbuying.com. Click here for my video about the MacBow X5, or here for more videos with my 3D printers. Either way, let's go print 3D or go cut 2D. Thank you for supporting Ergo Print 3D with all your likes, comments, and subscriptions.